Problem number 16. We need to find the exact value of the sine of 5 pi over 12. To do that, we're going to split this using either one of the sum or difference identities. So let's go ahead and use a difference identity. If I want to get 5 pi over 12, I need to think of two things that I know that subtract to give me 5 pi over 12. Or, if I use the sum, I can find two things that add to give me 5 pi over 12. So there are a lot of different ways of approaching this, and there's no right way. So one example that I showed in class was to actually use the sum. So I said I was going to do the difference, but let me explain the way that I did it in class for the sum. If I've got 5 pi over 12, let's just look at that. Okay, so this is not equal, so let's just put an arrow here. So remember that 5 pi over 12 is really 3 pi over 12 plus 2 pi over 12. And so that gives me pi over 4 plus pi over 6. So if I add these guys together, I'll end up back at 5 pi over 12, which means that I can replace 5 pi over 12 here with pi over 4 plus pi over 6. Now if I use my sum and difference formulas, I have the sine at pi over 4 times the cosine pi over 6 plus the cosine at pi over 4 times the sine at pi over 6. Sine of pi over 4, square root of 2 over 2. Cosine of pi over 6, square root of 3 over 2. Cosine of pi over 4, square root of 2 over 2. The sine at pi over 6 is 1/2. So this will give me square root of 6 over 4. This will give me square root of 2 over 4. So this is square root of 6 plus square root of 2 over 4. Okay, let's try problem 17. Oops, I wrote 16, I said 17. I want 17. There we go. We need to find the exact values of the sine of alpha plus beta, and we're given the information that cosine of alpha is equal to negative 12 over 13. There's some other restrictions there on alpha, and then also that sine beta is equal to some value and some restrictions on beta as well. So what we're going to do is we're going to say, okay, we need to find the sine of alpha plus beta. And we know that that is the sine of alpha times the cosine beta plus cosine alpha sine beta, just like that. So I need these four pieces. Well, what do I have? I have the cosine alpha. That's equal to negative 12 over 13. And I also have the sine of beta. That's this guy, which is equal to negative 3 over 5. What I don't have is the cosine of alpha. The sine of alpha or the cosine of beta. I'm missing those, but I can get those. So I'm going to draw out my alpha triangle. So my alpha triangle, we're told that alpha is between pi over 2 and pi, which means that alpha has to fall in quadrant 2. Now I'll draw out my picture of an angle that falls in quadrant 2, and its cosine is negative 12 over 13. So that gives me my adjacent side of my hypotenuse. That also allows me to solve, since it's a right triangle, to solve for the side length. So remember, this is alpha. So the sine value of alpha is then 5 over 13. So the sine value of alpha is 5 over 13. Now let's get the cosine of beta. For the cosine of beta, I need a beta triangle. So again, we look to see where beta is. Beta is between 3 pi over 2 and 2 pi, so that means it's going to be in quadrant 4. So we'll draw out our triangle. Just like that. Our sine value is negative 3 over 5. So that means it's negative 3 over 5, which gives us this length being 4. Again, Pythagorean theorem. So that tells me the cosine of this angle is positive 4 over 5. So now we just need to go ahead and simplify this. So 5 times 4 is 20. Over 13 times 5, I believe, is 65. A negative times a negative is positive. 12 times 3 is 36. 13 times 5 again is 65. So we'll add those together, and we're going to get 56 over 65, and that is our sine of alpha plus beta. Okay, number 18 asks us to establish an identity, which is that the cosine. So let me write down the problem number. I've been trying to switch colors for you so that it's easy to differentiate between problems. For number 18, it asks you to establish the identity that the cosine of pi over 2 minus theta is equal to the sine of theta. Now we can establish this with a picture, or we can use our sum and difference laws for cosine. So the cosine, this guy over here, this is the cosine of pi over 2 times the cosine theta plus the sine of pi over 2 times the sine theta. That's the left side. So that's just this right here. We need to show that it's equal to the sine of theta. So cosine at 90 degrees is 0. Sine at 90 degrees is 1. And so 0 times anything is 0. 1 times anything is that value, because that's the multiplicative identity. So this adds together to give me just sine theta. Okay, problem number 19. Problem number 19 asks us to determine cosine of 2 theta and the sine of theta over 2. So it gives us some restrictions. Now, what we need is the formulas for these. So cosine of 2 theta and the sine of theta over 2. So let me grab those. Probably the easiest one to start with, well, we gotta start with the cosine of 2 theta. And now there's 3 different versions that we have there that we can use. But if you look, the information that we're given is in terms of cosine. So if I want to grab one of those, I probably want to use the one that has cosine in it. So I'm going to use 2 cosine squared theta minus 1. Now for the sine, for the half angle, for the sine, we're going to use a different formula for that. Let me go ahead and grab that. Now I'm going to use the sheet that you guys had in class, that Jesse had found and volunteered for all of you. So to do this half angle here, if I look at the formula, what I have, okay, so I'm just going to grab this formula here. This is going to be sine squared of an angle is equal to 1/2 times 1 minus the cosine of twice the angle. So that's what the formula gives us. And now what we need to find is the sine of half of the angle. Okay, so what I'm going to do is I'm going to rewrite this like this. The sine squared of the angle over 2 should then be equal to 1/2 times 1 minus the cosine of the angle. So I want to get the sine of the angle over 2. Remember, this over here is sine theta over 2 times sine theta over 2. So what I'm going to do is I'm just going to take the square root of both sides. So this is going to be the sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2. Now this formula right here is the one that I gave you guys in class or in the notes. So I just wanted to show you that correlation between the two of them, or how they're related. So let's go ahead and grab this first guy. So we know that the cosine is 3 over 5. So this first one then becomes, so the cosine of 2 theta will be equal to 2 times the cosine squared of theta minus 1, which is 2 times the cosine of theta times the cosine of theta minus 1. So this is 2. Now the cosine of theta is already given to us as 3 over 5. Okay, so this is going to be 2 times 9/25 minus 1. So this is going to be 18 over 25 minus 1. So this is going to be 18 minus 25 over 25, which is going to be negative 7 over 25. Now let's think about if that answer makes sense. Look, the angle is initially given in quadrant 1. If we double it, think about an angle. Pick any angle you want in quadrant 1. Okay, now double it. Where does it end up? Well, it could end up in quadrant 1, or it could end up in quadrant 2. This one happens to end up in quadrant 2, and which would have a negative cosine value. So we're good there. Okay. Now let's go ahead and figure out the second one here. So the sine of the theta over 2 should be equal to plus or minus the square root 1 minus, now the cosine value again is 3/5 over 2. So that's plus or minus the square root 1 minus 3/5 is 2/5 over 2, which ends up being plus or minus the square root. So this is going to be 2 over 10. Okay, the reason that is it's 2/5 divided by 2, which is 2/5 times a half, which is 2 over 10. And that gives you 1/5 then if you reduce 2 over 10 is 1 over 5. And then to rationalize this, guys, remember this is what we can do. A nice trick here is multiply top and bottom here by 5. Now take the square root of each of those. Now the question is it plus or is it minus? Well, look, the original angle was here in quadrant 1. If you take half of that, it's still in quadrant 1. So the sign in quadrant 1 is positive, which means this is the square root of 5 over 5 for your solution.